In the shop today, we got a BMW E83 X3. This is a 2008, and you've got to admit, BMW do make sexy looking cars. You can't compare these to Japanese cars. I can see why people love them. So let's see what the customer complaint is. This car has what he calls a noise. The history behind it is it had a few issues that needed to be taken care of, and he took it to one of our local BMW dealers. They changed things like ball joints, coil springs, brake discs, stuff like that. But he said that they took the car apart to do all this work, and when they put the car back together, it developed a weird symptom, and that is a noise that happens predominantly when you release the car and let it coast when you're at highway speeds. He said about 80 kilometers per hour, something like that, thereabouts, you get this noise, and it's really disconcerting. So he went to another shop. The other shop did a couple of things, tried to diagnose it. Then they changed the transfer case motor because there was a dash error that they said was related to the transfer case motor. Change the transfer case motor, the errors went away, but what happens is, as long as the motor is plugged in, this car has a very bad noise. He says it's a grinding noise, and he said sometimes it holds back the car when he's driving, and it's pretty substantial. So what his mechanic did was to disconnect the transfer case motor, and as long as the motor is disconnected, the car drives fine, although he says the noise is there at a higher speed. Now that, to me, screams more of a vibration than a noise because of the change of speed. But anyway, we're going to test drive this car and see what it is. So right now the car has just been dropped off. The transfer case motor is disconnected. So we're going to go under the car, connect the transfer case motor, do a preliminary scan and see what's up with that, and then go on a test drive and then see, do we have a noise, do we have a vibration, etc. So let's go and see that transfer case motor. Alright, here we are out of the car, and this is the transfer case motor location. We're just going to remove this bolt here and gently peel that off, and there we have the motor, and true to his word, it's disconnected. The connector is neatly tucked up here, so we're just going to connect it back. There we are, nice and connected. All right, that's done. Let's go scan the car. All right, let's go ahead and do a health report. All right, there we finished scanning. Got a couple of codes. VTG transfer case, 2 codes. ABS anti-lock, braking system, 1 code. Parktronic, 3 codes. I'm not interested in that. SRS, not interested in that. And gateway, maybe. Let's just pull up a report and see what our errors are like. Let's generate the PDF. Alright, so we have the transfer case, the supply to the servo motor and then incremental transducer in servo motor supply. Now I don't know if those were induced because it was disconnected or it's present right now, but I'm not seeing anything on the dash, so I think those are history codes. Parktronic, ABS, transfer case internal, SRS, then some lane faults on the control. So here's what we're going to do. Let us exit from our report. And we're going to clear all those DTCs with the key off, put it back on. Let's clear the DTCs and then see what comes back, because that motor had been disconnected. I don't want to carry any faults forward and be led on a false path. All right, we're completed, and we only have the SRS and central body faults. So that tells me that those faults were stored. Start the car back up, and let's go now to the transfer case module. And we're going to go to the data stream. Let's see. Now, I do not like the way BMW programs in these scan tools do their data. I need to see different datas in different clusters, and this thing is clustered in such a way that you can only choose. You're restricted for choosing either the control module or the servo motor or the gearbox, clutch. I wish we could choose more stuff, but right now let's go to the clutch pack and we select all. So right now we have no clutch actuation. Let me put the car in drive. We're in drive. And let me just brake torque it. Let me just give it a brake torque. Here we go. Okay, so our motor is working. Our motor is indeed actuating. I don't know what these other PIDs are for. Plate integrator, etc. But I'm more interested in the actual and nominal clutch torque. So now we're going to go on a test drive and we are going to see what happens to our values. I wish we could have. Let me see if I can get other data to combine, because I would like engine RPM here as well. Well, unfortunately for me, my data stream is in clusters, because here we have different clusters and my RPM is found in the gearbox, but I don't need all these others. I wanted to see the RPM as well as the clutch information, so I have to restrict myself to just this clutch information. So we select all. It's a bit rainy today, no problem. Let's go on a test drive and see what is happening with this transfer case. Do we have a noise? Do we have a vibration? I'll put the camera off until we exit the estate, until we go to our open road, put the camera back on, and then we're going to test. So here we are on the open country road, and I can tell you this is not a noise. Well, it is. It's not really a noise, it's a vibration. There we go, if you can hear that. So the vibration at times is so severe that it rattles the body so hard that you hear the body vibrate, and the vibration of the body is what's causing the noise. But this vibration is coming from the floor. I can actually feel it in my feet, on the seat. All right, very interesting. So we found out that it's a vibration. Let me find a spot to pull over on the side of the road. I'm going to set up my tablet for a vibration analysis. So I want to capture the speed and RPM that we are going at, and then capture the frequency of that vibration, and then we're going to calculate it and see where exactly it's coming from. But this is an interesting one. Okay, I found a place where I've stopped and I want to capture this frequency. So what I'm going to do is put this in split screen mode. First, I'm going to open the vibration isolator. And that's open. Then I'm going to open the ThinkDAG. Then I want to put this on split screen. Split. And now we have both of them together. So the idea is to get the RPM, the wheel speed, and the frequency all in one capture. Now, since the BMW data is truncated in different sections where you can't put them together, we're going to do this from the OBD menu. I'm going to get live data, and we're going to search for vehicle speed, and engine RPM. All right, now that we have our speed and RPM, we are ready to take this capture. Now we can also get gears. Let's see if we have the gear, or shift. So we don't have gear position or shift position in OBD. So we're going to have to make do with just the RPM and the vehicle speed. So how this works is we're going to put this somewhere where the vibration can be felt. Like right now, I can pick up the engine vibration. By placing this on the steering. And I have somebody else in the car. You cannot do this as one person. You need two people. But let me just show you the engine vibration, because I'm picking it up on the steering wheel. So I'm going to hit start and then continue, if I can reach it. I'm going to pick the internal sensor, and you need to select which one vibrates the best. On this one, it's the last one. And if we hit start and we wait, there we have our frequency. So we know that at around 712 RPM, we have these two frequencies. So that is how we're going to pick up the vibration of the car. So we need to find a place where the car vibrates the most. On this car, it is going to be somewhere on the floorboard. I have someone sitting at the back, and they're going to press this on the floorboard. And then as I drive, when we feel the vibration, we're going to take a capture, and we keep taking maybe 3 or 4, and we'll analyze them later. It'll make more sense once we begin the analysis. So what I've noticed is, if you put this thing in Triptronic mode, where you can manually shift the gears, I've noticed that if I shift into 3, I get my highest vibration. At that point. All right, so I've trapped it in third gear, and I'm just going to go let off here. Tick. And that's a nice strong vibration. There we go. That's what we wanted to see. So that's the vibration we have. Let me just find a place to stop quickly and I'll save this capture. Okay, we are back at the shop next day and we are going to do an NVH analysis. A tip for you technicians out there: do yourself a favor. If you do a lot of diagnostics, learn how to do vibration analysis. If you become good at vibration analysis, you will literally triple the amount of money that you will make in diagnosis for sure. This is something that very few shops can do. Get yourself this knowledge and make sure that you learn how to do vibration analysis. Maybe I'll do another video on vibration analysis. You will thank yourself once you learn this stuff. So before we analyze our vibration, what we want to do is to analyze the drive system of this BMW. So here in my TIS, I'm going to go to functional descriptions, powertrain, and transfer box control unit. So transfer box control unit, functional description, C, vehicle technology, diagnosis, VTG. Let's go here. So this is the X drive system. You have got an electromechanical transfer box in the middle there, and it is connected to the rear axle via a diff and the front axle via a diff. So you've got two propeller shafts, this one, and this one behind here is a two-piece shaft with a center bearing over there. I'm not going to go into the technical X-drive system, but basically what you have is a motor. Let me go to here, system overview. You have a motor, which is number 4 over here. This motor actuates some clutches and connects this drive shaft to this drive shaft. So this is the idler drive shaft when you're not in actuation mode. When it is actuated, you connect this to this. So if you go back, the front drive is the one that is connected by the transfer box. The rear drive is permanently connected by the gear train, the gearbox. Very simple. Now, we don't have a problem with our transfer case, so I'm not going to waste too much time here, but we have a vibration that we need to analyze. Next, let's go to the vibration that we picked up yesterday. So this is the vibration that we got yesterday. So this is just a spectrum, and it shows the strongest vibrations that we got. The strongest vibration is 50.27 hertz. So we're going to mark that down. And we have to know the engine RPM and the speed. Now this app has a beginning point of measure and an end point of measure. So all this is between 0 and 100% of that measuring degree. So let's go to the beginning. Right here at 0%, our engine RPM was 2536 and our vehicle speed was 46 kilometers per hour. And then at the end of the capture, our engine RPM was 2082 RPM and our vehicle speed was 38 kilometers per hour. So we're going to start with 46 kilometers per hour and 2536 RPM, and we need to plug this into our NVH calculator. Before we plug it into our NVH calculator, we need to know a couple of things. So let me just open the calculator. This is my NVH calculator that I have set up. It gives you the frequencies of the tires. So T1, T2, T3. First order vibration frequency of the tire, second order, and third order. Then RD is rear drive shaft. So rear drive shaft, order 1, order 2, and order 3. FD is front drive shaft, order 1, order 2, and order 3. Then engine vibration, order 1, 2, 3, and 4. And then if I have the gear ratios, here we can have gear 1 to gear 7 and order 1, 2, and 3 respectively. Now, for this to work, we need to plug in the correct tire size, the rear diff ratio, front diff ratio, and then the gear ratios. We either get this from technical data or we measure it ourselves. Lucky for us, with a bit of digging around, I saw that BMW have listed it in their technical data, so I put it in my TIS. So let's go back. General information and vehicle technical data. Let me zoom in here just a bit. Our vehicle is an E83 X3 2.5 SI, and we have two here. We either have an M6 or an A6. M6 is the 6-speed manual transmission. A6 is the 6-speed automatic transmission. Ours is a 6-speed automatic transmission. And if you go down, a couple of things we need to look for. The first thing we need to look for is the gear ratios right here. So here we have gear ratio, first, second, third, fourth, fifth, sixth, seventh. So we won't have a seventh because we are 6-speed. And they are listed here. 4.065, 2.371, etc. up to gear 6. So gear 1, 2, 3, 4, 5, 6. Those are gear ratios. And then the next thing we look for is the final drive ratio. So the final drive is the differential ratio. Here we have a final drive of 4.44 ratio. Now our final drive is the same rear differential and front differential because this is an all-wheel drive system. So both rear and front are going to have 4.444 ratio. Then the last thing we need from this is the tire size. Now the tire size don't depend on this document. This document should tell you what the recommended tire size is, but always check the actual tire size that is physically on the vehicle. A lot of people change tires without regard to the vehicle specifications. So here we got front tire, the type, and the rear tire. And here we have 235 55 R17 for both front and rear. And I have checked the car actually matches this. So now with our specs, we can fill in our NVH calculator. So let's come here to the tire size, 235 55 R17, rear diff ratio 4.44, front diff ratio 4.44. Then we fill in our gear ratios over here. Gear 1, 4.065. Gear 2, 2.371. Gear 3, 1.551. Gear 4, 1.157. Gear 5, 0.853. And gear 6, 0.674. Now let's come to our speed and RPM. Now here we have to be very accurate. First of all, we have to understand that the app that we are using takes some time to calculate these frequencies, and then it calculates the strongest frequency at any one time it gets. So the time it moves from 0% to 100%, anything that is the strongest will appear on that graph. But we do not know at which speed and at which RPM it appears. But that is not a problem because we have our spectrum. So if you go back here, when the app started calculating at 0%, it started calculating with an engine RPM of 2536 and a vehicle speed of 46. And it ended with an engine speed of 2082 and a vehicle speed of 38 kilometers per hour. So we're going to go to the beginning, 2536 RPM and 46 kilometers per hour speed. We're going to fill that in our calculator. 46 kilometers per hour, 2536 RPM. Now, this is the important part. Stay with me here. What we have currently here is the frequencies of all the rotating parts of this vehicle at the time of our vibration. What is closest to our frequency? Let's go back to our graph. And on our graph, we see that our frequency, the strongest we picked up was 50.27 hertz. So 50 hertz. If you go back to our NVH calculator, 50 hertz in this entire chart comes close to only two things. First, it is second order drive shaft vibration. Here it's 52.32. And then the second one is second order gear 1 vibration. We know we were not in gear 1. We were in gear 3 while we were taking this capture. So definitely this doesn't apply. So our frequency closest aligns with this. Now we need to match up the speed. Since we know it is a drive shaft vibration, it's going to be influenced by this speed. So we need to match up the speed here to a point where we are going to get around 50 hertz here. So let me go to 45. Remember, this was the highest speed, and then we're going all the way down until we ended our capture. So let's go to 45, 51, 44, 50. So now we were at 44 kilometers per hour when we got a drive shaft vibration of 50 hertz, second order vibration. But we also have to match our RPM. So we have to look between 0 to 100% at what RPM were we having a speed of 44. And I have that capture right here. So here we see that at 44 kilometers per hour, we had an engine RPM of 2424. So now let's put it in our calculator, 2424. And this is our frequencies at the exact driving conditions that we got our vibration. Engine speed of 2424 RPM and vehicle speed of 44 kilometers per hour. If we look at our engine, we see that our engine is not vibrating at that frequency. Our gearbox is not vibrating at that frequency, but our front and rear differentials are vibrating at that frequency. Now that we know that this vibration is coming from the drive shaft, we have to isolate where is it. Let's go back to our X-drive figure. So now in this figure, we are either vibrating on the front differential, the front propeller shaft, the transfer case, the rear propeller shaft or the rear differential. These are the only 5 items that are vibrating at 50 hertz. So, who is vibrating here? Now we have to be extremely careful here because all these parts are extremely expensive. If you watched my video for the other BMW that I diagnosed a bad steering rack, you will see how expensive that unit is. So we have to make the right call here so that we buy exactly the correct part. So how do we eliminate these? The answer is we need to use an accelerometer. And we have to place this accelerometer in 3 places and go and drive this car until we get the vibration. First item we will place our accelerometer is the front differential. The second item we will place our accelerometer is the transfer case. And the third item we will place our accelerometer is the rear differential. Now, of course, we cannot place our accelerometer on the front or rear propeller shaft because it is spinning around. That will not work. We need a stationary object. So when we do that, we will go for a test drive and see who amongst these 3 is giving us the highest vibration. Now, after we find where the strongest vibration is coming from, we will need to eliminate whether it is coming from the propeller itself or from the item that the propeller is connected to. And just a quick one before we set up our accelerometer. The question is, why are we using an accelerometer instead of a microphone? The answer is, this is more of a vibration than a noise. You use the correct tool for the correct application. Microphones have to do with noise. Vibrations are picked up more by accelerometers. So that is why we are using an accelerometer instead of a microphone. Let's go. So what we're going to do is to take my accelerometer. This is the ADXL 335 accelerometer. It's a homemade accelerometer that I've made, and it's a 3-axis accelerometer. So I'm going to put it on the front differential, go for a test drive, and get the highest amplitude on gear 3, and then put it on the transfer case, repeat that, and then put it on the back rear differential and repeat that. So let me go and mount it on the front. Okay, I've set up my picoscope, and there's my power source, 9 volt. Now the ADXL 335 is not a 9 volt sensor, it's a 3 volt sensor. So I have a buck converter next to the sensor in that box, and it will convert this 9 volts into 3 volts for the sensor to work. I have set up my scaling. I'm doing an AC coupling on this one so that I only capture the amplitude of the vibration. That's what I'm interested in. Alright, there's our vibration. Stop that recording. And we're going to go back and repeat with the transfer case. Alright, there's my second capture for the transfer case. This housing is aluminum, so I've put it on the bolt that is for the drain, which is steel. Alright, our last capture is at the rear diff, and I have a clothes clip on that harness so that it doesn't fall down and drag my sensor down with it. Alright, let's go for a test drive and see what that one produces. All right, now we can clearly see that that vibration is coming from the rear differential. I want to go back on a test drive and I want to focus on that green channel. So we're going to turn channel A off. Actually, instead of turning it off here, we're going to just hide it from the screen. So I'm going to hide A and I'm going to hide B and leave only the green. So let's go on a test drive, and what I want to do is to get this thing to really vibrate. I was going at a low speed. I was going at about 20 kilometers per hour, 20 to 30. So now to do some acceleration, maybe until 80, and I want to get that diff to really vibrate, and I want to see my amplitude go sky high on this green channel. Let's go. I'm going to put on the AC. It's mad hot in here. I don't want my laptop to overheat. Alright, now I'm going to keep it in drive and go a bit faster. Now we're vibrating. Oh, and the vibration is stronger now. It's kind of going in and out. And exactly what the scope is doing is what I'm feeling. There is a very strong vibration. Vibration is gone. So yes, confirmed 100%. This is coming from the rear differential. Now, what I want to do is to trap this thing in third gear. Right now I'm in drive. Let's go to electronic third gear. And then I will accelerate. That's a much stronger vibration now. Yes, that's a very strong vibration. And, oh, I missed that one. But you saw that vibration was really high. Let me try and repeat that and pause the scope. Yeah, let's accelerate. And there we have a very strong vibration there. And let me pause that. That's a good capture. Let me save that, go back and analyze that, but we're done. This is a rear differential vibration. Right, we are almost done. We are vibrating on our rear diff, but we have now to isolate. Is this the rear differential that has an internal problem, or is it the prop shaft that's out of balance, or is it the cardan joint that is on the prop shaft? Now the cardan joint, I think Americans call that a U-joint, universal joint. Brits call it cardan joint. Now, this is a second order vibration. Because of it being a second order vibration, we can already eliminate the fact that we have an imbalance on the prop shaft itself. Imbalances only produce a first order vibration, never second or third. So we don't have an imbalance on our prop shaft. But the cardan joint can produce a second order vibration because it has got multiple places where it can play around. And the internals of the diff can also produce a second order vibration because of the gears and everything. So we either have a problem in the diff or we have a problem on the joint. Those are the only two possibilities. So now let's eliminate. What we have to do is to lift up the car and then examine this joint for play. If we do not have play on this joint, then our problem is only in the internal differential. Those are the only two places. Let's go there next. I have lifted up the car and let's go under. So we are under the car. It's not easy to view this propeller because there is this cover here this cover stretches all the way to the center of the vehicle, and you have to remove those two members over there. I'm not going to do that. I have removed some bolts here. There is another cover that comes before this one, and that's this one down here, which it's already removed. So if I peel this back, I can actually get access to our joint. So the first thing I want to do is to just shake it, and we do not have any play on this joint while I'm shaking it. But what I've learned is usually you're not strong enough to do this unless the joint is so badly worn. So what I'm going to do is to turn that wheel up and down just slightly while I'm examining this joint and listening to it for play, and then I will know whether we have an issue there. So let me set this up on a stand. Okay, here we go. I'm going to move the tire up and down. And I can't see anything, but I can hear a clunk. And if I put my finger, oh yes, we are done. This joint actually has play. Is it radial play? It's actually playing in the rotational direction of motion. So this joint is worn out. It is junk. You cannot replace this joint alone. It is a non-serviceable joint. That's it. Bad rear cardan joint on the propeller shaft, producing a second order vibration. Awesome. Okay, how cool is that? This is a wonderful diagnosis. Propeller shaft needs to be purchased to fix this vehicle. Now, this owner had already settled on getting the transfer case. In fact, it was a done deal. He was given my number and he just wanted me to confirm that diagnosis. But he was basically done. He was purchasing it. That would have been a very expensive mistake. Imagine putting an entire transfer case on this car and you still have the same issue. This is not a transfer case issue. He needs to buy the rear propeller shaft. Now he knows, lucky for him, it's a cheaper component than either the transfer case or the differential, and he'll be happy, I'm sure. This car will be back on the road once that is done. I don't think I'm the one who's going to do it, but if I get to do it, I'll bring you along on the journey and we will do a confirmation that the vibration is done. I hope this convinces you that you need proper diagnosis. Evidence-based diagnosis is the only way to go. Another one for the books. Call me. You know you want to. Until next time.